Today we're going to make a baby lava lamp. We're starting with 450 milliliters of water in a beaker. This is where our entire experiment will take place.
You're going to measure out with your pipette 100 milliliters of vegetable oil in a graduated cylinder, because that is the most precise measurement. You're going to have to read from the meniscus, or the little dip, and make sure you get 100 milliliters.
Get it. Whoa, what the heck?
Going to pour in the vegetable oil, and notice how it rises to the top of the container. That is because it's less dense than water, so it has a density of less than 1 gram per milliliter, and they are immiscible of each other, which means they will not mix.
Okay. Now we're going to add a few drops of food coloring.
Notice how the food coloring and the vegetable oil are also immiscible of each other, and the food coloring is also less dense, so it will.
The food coloring is equally as dense as the vegetable oil. And then as we add salt, it's going to take the food coloring down, and food coloring and water will mix. So as you notice, the food coloring will start to dissolve into the water.
If you'll notice, little bubbles will appear and rise to the surface, and that is because when the salt is poured in, it drags down some of the vegetable oil with it. And when the salt dissolves, because it is soluble in water, the trapped vegetable oil will rise back to the top, and the salt will fall, rise back, creating sort of a cycle.
It looks like a miniature lava lamp.
Yes. Over here, we have sort of particle diagram. The vegetable oil here, you'll notice, has less particles because it does, which makes it less dense than the water here, and the salt is denser than both the water and the vegetable oil, and it will sink to the bottom.
Yeah.
So that is how you make a baby lava lamp. Okay, this is a heating and cooling graph. The direction of heat flow is from hot to cold because it goes from hot and the particles will spread out, cold, and that endothermic change is when heat is added. And so if you start with a solid right here, the temperature will increase gradually until it hits the melting point. And when it hits the melting point, the temperature will not change. It will stay the same, and then when it becomes a liquid, the temperature will increase and continue to increase until it hits vaporization, which can be achieved through either boiling, which happens below the surface, or evaporation, which happens on the surface. And once again, the temperature will not change. And then when it hits gas, the temperature will gradually increase until ionization. And ionization is when the gas particles become charged, and it enters the fourth state of matter, which is plasma, which has charged particles. And so, if you go from a solid, liquid, gas to plasma, it is phase changed each time from because there are 4 different states of matter: solid, liquid, gas, plasma, and these 4 go from from slow-moving particles all the way to fast-moving and charged particles. And then you can go exothermic change, which is when the flow goes back down. So a plasma, to get back to a gas, will have to go through deionization, where the particles are no longer charged. So when it hits gas, the temperature will gradually decrease until it condenses and forms water droplets, turning into a liquid. And during deionization, condensation, and freezing, the temperature does not change. So when you hit a liquid, the temperature will gradually go down until it hits its freezing point. And when it freezes, it becomes a solid. And once it's back to a solid, the cycle can start itself over again, or just stay as a solid. So endothermic, exothermic, the four states of matter, and this is how they get there.